So flaky tests are bad because they make development very slow and annoying, because we don't know why they fail, but they fail sometimes. And basically what people do when they see flaky tests, they first decision is to just delete the test to make it disabled. The second decision is to make it less strict, less demanding, like we discussed. Obviously, the first decision is the worst. The second one is maybe not as bad, but still bad, because it leads to making tests less effective. Because if they don't, like in this example, if we check for 100 here, then maybe we're gonna miss some important bugs here. Maybe some of those runnable. But I mean, in this case, it's not gonna happen, because here we only test the simple functionality of just printing the XML to string. But in other more complex examples, we may, with jumping from number 3, which let's say was here, jumping to number 100, we may lose the sensitivity of the test. The test will be less sensitive than it was before, and this sensitivity is important. So what is the right approach in this case? Let's say this test is flaky with the number 3, so we don't want to increase the number. How do we do that? We still want those 50 times to be the XML document to be printed, and we wait for all of them to finish, but they don't finish. We need to provide some timeout. I'm just thinking how to do it right. So what would be the right, and maybe there is no right way, maybe there is the only possible way is to make the number large, but we can well, we can, for example, let's put it this way, we make the test a bit larger. So let's say in this runnable, we introduce another, maybe, I'm just fantasizing. So maybe we introduce another set of, let's put it this way. So let's just count the number of done tests. So we assert here and we have done, and we just increment. So all those tests, they will increment one by one, and here we shut down the service. Then we, instead of waiting for the termination, we say done. Can we wait here? We can wait here, okay. Then we do like this, maybe. Again, very primitive, but if all of them reported as done, then we break the loop. If we still waiting, then we continue. If we wait for more than, I don't know, if we wait for more than some time, no, maybe the timing is not a good idea. Maybe here we can do wait for the termination, something like that, 1 second. Maybe we can do even, I don't know, 10 milliseconds. So we just wait a little bit. Why it's red? And then So I think now the test is not flaky. So we will wait in the loop. We will wait for all of them to report back to us that they're done. And at the same time, we're going to wait for the termination of all of them. So if we jump out of this loop, then we for sure will have this return true. So if let's say it's a positive cycle, so everything goes well. So in this case, we will eventually hit this line, we'll break the loop, and this line will also be true. So everything will be okay. Let's say everything goes not well, so it takes longer. I mean, they're slow. Let's say they're very slow computer. So in this case anyway, we're gonna loop for quite a long time, and eventually we're still gonna break. I believe. Let's check. So my point is that now we don't have this magic number 3 or magic number 30, because these numbers are not magic. This 1 and 10, I can put any numbers there. You see? So now 6 seconds, but it doesn't matter what the numbers are here. I can put 1 here, I can put 100 here, it doesn't matter. So all these numbers, they just don't mean anything. But the test now does not have any hard-coded number of seconds. You see? So I changed the logic. The test now is a little bit longer, but now it's not flaky anyhow. 1 doesn't matter how much time. Only this number only matters because it will be a little bit slower, because I will check more. More frequently, every millisecond. Now I was checking every 10 milliseconds. Now I will check every 1 millisecond. So maybe execution will now take, instead of 6 seconds, it will be maybe 7 seconds, because I check more frequently. Okay, the same, say 6 seconds. So now nothing is here. There's no magic numbers in this test anymore. So this is the right approach, right way to make the test less flaky. Instead of making it less strict, make it more strict. In this case, it's more strict. In this case, it's more smarter, maybe more intelligent, I would put it this way, if I can say that about the test. Because before, it was my test before, but I think this one is much better, written much better, but longer. So it was much easier to write the test I wrote before. Maybe I didn't have much time, so that's why I put like there, this magic number. Let's wait for 30 seconds, and that's it. So don't do it. Don't resolve flaky tests by making them less sensitive. Instead, make them more sensitive. Make them more precise. Because before, this test was not precise enough. The test was just generic, just too imprecise. I think that's the right word. Okay, now let's talk about different types of integration testing which you must use, but which are very difficult to use. Stress testing, performance testing, load testing, penetration testing, that kind of tests, which also must be automated. Ideally, they must be automated, but it's very hard to do. And most people just don't do it, and most people just don't put those tests into the build pipeline. They do those tests, but they do them manually. They say, I have an application, I want to do performance testing, so I just run my web application, I load some traffic on this application, I see the statistics, and then I say, okay, my application can run successfully under the traffic of 50 requests per second. Good, I did my load testing. And then my application can handle the peak traffic of 1,000 requests per second during half a minute. And then it just stops responding. So I did my stress testing. But those tests are accidental, and those tests are just occasional. They have very little, they give very little value to the project, in my opinion, because you do them only once when you have desire for that, when you have the time for that, and it's very hard to reproduce and very hard to interpret the results. You collect some results, you know some numbers, what do you do with these numbers, how to interpret them today, what to do with them in the months, in a year, we don't know. So ideally, in a good project, you have to automate. Let's start with load testing. So you have to find a way how you can automate the load testing, which is, you know what is load testing? When you have some application, some software, then normally this application should handle requests one after another, for example, or maybe in parallel, a number of requests in parallel, but it's just a normal traffic. But the question is how much you can put on this application, how much traffic, so that it doesn't stop answering. You can. I'm thinking, what is the problem? Why most of us don't put this into the automation cycle, the pipeline? And I think the answer is that because, well, first answer, because it's slow. So it needs to, when you load the traffic on something, when you load too much requests or too much data on some application, then you should be prepared for this application to behave abnormally. And maybe the server, which is handling this application right now, will also behave abnormally. Maybe it will just go down and the operating system will fail. Anything can happen. So you basically create an extreme situation for the computer, and you don't want this extreme situation to be created on every build. So you commit something to the master branch, and then all of a sudden the super high load is happening on the continuous integration platform, and everybody is sitting and waiting, asking what's going on, why the server has the load average of 100. Oh, now we understand it's a test running. And then this test is happening every hour or every 10 minutes, depends on how often you commit. And this situation will definitely stress people around and will not make them happy. So that's the first reason. The second reason is that it's hard to guarantee that the results collected from this load test on one computer will be exactly the same as you collect on another computer. And most probably they will be very different. And the test is supposed to be green or red. So we don't want to write test just for the sake of running a test. We want the test to give us a signal. Is it red or is it green? And we want to react on the red signal somehow. So the question is, how do we understand what is red in case of a load testing? So I have an application, I put some load traffic in there, and then what? So how many requests it has to handle, depending on the computer which it works on. There is no clear answer for that. The same for the stress testing. So if you just make a peak traffic, if you, for some short period of time, make a peak traffic on the application, then you want to have some metrics. You need to have some numbers to compare. This is what we had yesterday. This is what we have today. And yesterday was better. Today we have worse results. And I'm going towards the idea which in my experience people use quite effectively. So the difference between these type of tests and a traditional integration test is that load test, stress test, and performance test, they must be how to say, incrementally evaluated. So instead of checking the results of test now, you just collect the statistics and then compare the statistics with the yesterday statistics. So on some platform, on some place where you run the tests, you go through the tests, you collect the statistics of how much load it can handle, how much stress, what is the performance, and then you collect the numbers about the computer. Let's say you have a dedicated computer for that, so that would be a good scenario if instead of a virtual computer you have a real computer. But even if you have a virtual computer, it's still doable. So you collect some numbers and you put those numbers in some file. Maybe you publish those numbers somewhere in some place where you can publish artifacts. And then when the new version comes in, then you run again those tests and you have new numbers. And you compare those numbers with the yesterday numbers. And if the difference is bigger than some threshold, then you fail the test and you say something happened, something is wrong here. So I think that would be probably the best approach to performance, stress, load, and tests like that. To compare if you degrade or you improve. So if your application degrades in terms of response time or in terms of the maximum load it can handle, then probably it's a good reason to reject the build and not accept the new version. It's still hard to. Well, it depends on, of course, not on every push to the master branch, of course, but definitely on every build. Definitely when the team is ready to release the build and say this is the new release, version number 0.5, then definitely you run the full test. And actually this is a very good comment because I wanted to tell you about this as well, that very often I see people have large amount of tests developed. In GitHub Actions, they have many jobs, in this workflow, they have many jobs configured. This test is testing this test is testing that. So many very well-developed structure of the tests. But when I ask them what happens when you want to release the new version, then all of these tests are just ignored and the release happens instantly. You just click the button and the release goes out to production. It means that they somehow, they behind the scene, they agreed to each other that we're gonna manually check all those statuses of our tests, and if everything is green, then I will release the product. But this agreement is implicit. This agreement is not checked automatically by any software. And most probably tomorrow somebody will forget to check that. Somebody will just forget to check all those green or red signals from GitHub Action, for example. And the new release will go to production without the checks and definitely with the broken test. So it's very important that the build pipeline, which ends with a new release, goes out to production. This pipeline must involve all the tests which you develop. And if it takes 2 hours, it's okay. If it takes half a day, it's okay. It shouldn't be short. It shouldn't be just a few seconds. A few seconds is for unit testing. But the build pipeline, which finishes with the release, must be the longest possible, the longest you can imagine in the project. But I see situations where people have a lot of things configured on their CI servers, but all of that is ignored when they go for production. So that's the recommendation for these tests which require the analysis of the speed of the software or performance. This must be done incrementally instead of how would you say it, the instant evaluation of the current status of the repository, of the product. There's also one interesting type of testing which I also wanted to show you. I don't know how to call it right and what is the right name for it. I call it credentials testing. So let me describe the symptoms of what's going on, of what happened to me in a number of applications, and that's why I started doing those tests. So let's say you have an application and this is a web application, so it is hosted in some platform. And in order for this application to work, it needs to have some credentials to connect to some external resources, database or whatever. When you release the product to Heroku, for example, then you provide those credentials somehow and the application connects to, let's say, database and starts working. Everything works good on the testing, in the integration tests, because it creates a fake instance of Postgres, for example. Postgres is PostgreSQL, Postgres database, and in the tests everything is fine. But when I deploy there, the application crashes on the production server because credentials are wrong. So the access which I give to my web service, the access I give to the database, it doesn't work anymore. But I never tested anyhow. I just run my unit tests, I run my integration tests, I test it against the fake Postgres instance, then it goes to production, and boom, I go to the website and it's down. So what do? How does it happen? It shouldn't happen. I mean, this is the idea of the build pipeline. So if the build pipeline is green, it's a 99.999% guarantee that production will be green as well. If there is no guarantee, then there is no point of having the build pipeline, because without this guarantee, I can just put the code directly there. Why I need all this hassle with the unit test, integration, everything? I can just put it there if my pipeline is not a guarantee. So ideally, we need to build, to create such a pipeline, which is a guarantee for my stability on the production server if I'm stable on the build. But credentials make a problem. So what did I do? I'll try to find now. I think it exists here as well. No, it's not in this project. So maybe I don't think I can find it now, but the idea is simple. It's just a simple script. What it does, this simple script, after the whole pipeline is done, after my unit test integration and everything is done, including static analysis, style checking, everything, after that, I take the credentials when I run the build, I take the credentials, the file with credentials, and make a number of requests. Not from the web application, but just from the script, from the build script. So inside the build script, I integrated the small check, which uses the production credentials and connects to the database and just reads some data from some table. That's it. Just to make sure that this connection is doable, that the credentials are correct. That's what I call credentials testing, and it helps me in a number of applications. So it may help you as well, because we cannot trust that the target platform will run everything correctly if we don't check it before. So that's what I wanted to tell you. Another type of test, which is also. But first of all, let me draw some bottom line here. I'm telling you about different types of testing because I think that it's important that you have the mentality like the following. The more tests you have, the better. The more tests you have in your application, the better, the more stable the application will be. Different types of testing. Of course, there has to be not a balance, but there has to be an understanding of what these tests are doing. Like I told you, if you're going to create many unit tests, which all of them are integration tests, and they're all slow, then you're not going to do yourself a good favor. But if you do the tests correctly, then the more of them you have, it's always the better. We discussed, I think, some time ago, the anti-patterns, testing anti-patterns. So I again recommend you to read about that. There are many of them, many of those anti-patterns. I think even more those anti-patterns than in software, in the live code. So for tests, people wrote many recommendations of how you should not write your tests and what you should do instead. So I think you need to read about that, because bad tests are, especially if there are many of them, then the badly written tests definitely are, well, they're not really a problem because people will just delete them. So if you write many tests and while you're writing them, you will be excited, you will like what you do, you will create many of them, they will all work while you're making them. But then in some time, when something changes, your test will just stop working, they will just start failing, and nobody will understand why, and people will just delete them. You, not people, you yourself. You just come back to your application in a few months, and if you see the test, which you don't understand what it does, you don't understand why it fails, what you're gonna do? You're gonna disable it. That's the best you can do, because what else? If it's hard for you to understand why it fails, maybe become, for example, it's flaky, but for not so simple reason like I just showed you before, but for another reason, then you won't be able to understand what to do with the test. So in this case, it was more or less easy to figure out how to make it less flaky. So writing bad tests is a bad favor for your project, but not really, like I said, it's not really damaging, because it's not gonna break the production. But what happens, it will look like this. You write the test, you commit it, then in some time, you or somebody else come back to this source code, try to do something there, run all the tests. Some of them fail because of the anti-patterns which you use. People will just delete them, but they were actually covering something. So the tests, they were there for a reason. And then we delete them because we don't know what they do anymore. So they just go away, and it means that some parts of the live code is unprotected now. And unprotected code means that we again will most probably see some bugs in production. And actually, maybe the tests which became unstable, or maybe became just stable red, they were the indicators of the problems in the live code. But we don't know what problems, and we just disable them, and that's it. So making good tests is a great help for the project. It's art. I mean, it's hard to do. It's maybe it's harder than writing the code. Actually, you know, that's a very it's a long story about people arguing who's more important, a tester or a programmer. And this war between testers and programmers is going on for years. And there are books about that, like really books explaining the difference and arguing that testers are now second-class citizens, that testers are paid less, that testers are less important in software projects, that testers are usually, they're junior programmers, they're like you guys, they're students, so they take students, they make them testers, and then they grow, and then they become programmers. While there are people who say the opposite, and the books and the papers and articles who say the opposite, they say that programming is the task of the first level. The second level is testing, because writing code is easy. You just write the code and tell the computer what to do. But testing is you need to explain the computer how to break that code. So testing is more destructive activity and an activity which takes more brain power, because you need to invent the methods of how to penetrate the code which you have, this black box usually, and in automated way, and then somehow collect the data from there, which will tell us whether the code is stable or not stable. So I think I'm on the second side. I believe that testing is way more complex activity than writing code. But unfortunately, the market is different. So if you start looking for a job and you tell them that you're a tester, then you're definitely going to get twice as less money. Maybe it's not exactly the number, but definitely less. And people I don't know, maybe not very few, but maybe no companies. Okay, very few companies, they have positions for, like, dedicated positions for automated testers. They have positions for manual testers, the people who manually click the buttons and basically try to simulate the real user, and then collect the bugs from the software. But people who write automated tests, not so many. There are teams who write, I don't know how it's called, it's not automated tests, but they're automated, but they what's the right name, when they design the scripts for UI testing, widget test, midget tests, maybe something like that, I don't know the name, where you basically not write the code, you write in some script, in some language, some meta language, some domain-specific language. When you say maybe like in Selenium, for example, it's a good example. When you just give commands and say, go to this screen, click this button, then move the mouse there, click another button, enter this code, and so on and so on. This is also automation. But I would not compare that with writing integration tests or writing unit tests, because it's not a job of a programmer, it's more a job of a like business designer, business case designer, and people who know what the application has to do, and they just smart enough to understand this specific language with a few dozens of commands. But this automation is also good, definitely good, but to my knowledge, it's a different story. Maybe it's not a subject for our discussion here, because we are discussing more like lower level testing, where have you heard about behavior-driven development, BDD? It's called BDD. Yeah, which is related to what we're talking about. That's why I mentioned it. It's the concept of writing tests where you specify. I can show you an example where you specify. Hold on. I'm thinking, okay. So this is the test script written with the BDD style of writing a test. So you can see it's English, more or less plain English, but it is structured in so-called scenarios. Scenario 1, scenario 2, scenario 3, and so on. So each block of text is a scenario. It's a Ruby command line application. So first it says, I have a feature, command line, this is the title of the feature. And then I say a description of this feature. I say, as a source code writer, I want to be able to call this PDD command line tool as a command line tool. It's just plain text. This is the description, and that's a plain text. Then I say scenario. In scenario, I say the title of scenario. I say the help can be printed. And in this English text, I say there are three words which each scenario can start with. The word, this one, let's take a look at this scenario because it's quite large. The word first is called given. Given says like, when I say given, it means that there is some prerequisites, some resources, some usually files, which need to exist before the test will start. And then in plain English goes the description of what I expect. I say, given I have a file with this content, and then I provide the content. Then I say when, the next one. So this was the start. The BDDs contains usually three parts. Given, when, and then. Given explains what I have in the beginning. Then I say, when I run my script, my tool, with these command line arguments, then exit code is 0. And then I continue, and standard out contains this, and XML file this, which will be created, matches this XPath, and XML file matches this. So how the computer understands this? It looks like plain English, so how the computer will understand that? Because this is the script, so when I run using Cucumber is the software for Ruby, the Cucumber is the processor of these files like this, formatted like this. So Cucumber can understand it, run it, and print the result and say success or not success. So instead of writing in Ruby, I'm writing in plain English. It sounds like fun, right? It sounds like more understandable way, because the idea of BDD is that we can give this file to a non-programmer. This is for programming, for command line tool. Of course, this is for programmer. But imagine this would be for a web application or mobile application. So instead of writing the Java code, I just write the code like this in the scenario. Using this application, I can post a picture on internet. Given I have a picture file, when I click the button post, then the picture is on internet. Any business person can understand that if we explain everything in these scenarios, and we have a long file with all these scenarios, then we will have non-programmers understand this. So how it works technically, because we're programmers, so let's take a look at what's inside. For each of these phrases, we have a file called steps. And in the steps file, we explain what each feature, for example, given, and there's a regular expression, I have a file with content. So it says, when you find this text, then it extracts the file from here and extracts the text. The text goes, everything which goes after it. And then I do the normal, like now we go for programming level. Now this is Ruby programming. Then say, when I run PDD, then, so it's basically, here we explain what to do for each piece of text which you're going to meet in the code. Given I have a sample Java file with content, it's going to match here. You see? Next one. I say, when I run with, it's going to match here. When I run bin PDD with these parameters, and so on and so forth. So basically we create the language first, we create the phrases which needs to be understood, and then using those phrases, we write the code. And we get the large script which you can easily run. If you go, let's say we do it Cucumber, that's the name of the tool which does all that. Oops. No, it's not Cucumber, it's features. They call them features. So each feature, this scenario, not the group of scenarios, is like one feature. You see? It executes them feature by feature. It doesn't print the details for some reason, but we can make it do it. Here's the configuration of how it should work. That's Cucumber. This is we configure, so I guess we remove this just for the sake of argument. Let's do it again. It will print more details. Not just dot, but will show us everything. You see? It shows us how it understands each piece, each scenario. So it's like more advanced unit testing. It is, maybe it's not. I wanted to say it's popular, but I don't think it is as popular as its creators wanted it to be. But it's somehow popular. See? 25 scenarios, 118 steps, 25 business scenarios, all written in English. You see, it gives it, given, and here it shows at which step we finally landed. So which step was actually executed. That's called BDD, behavior-driven development. And Cucumber is the tool to automate that kind of test writing. This is popular for Selenium as well. I think there is integration between this Cucumber and similar tools and Selenium, because writing tests for business, it was always a dream for many people, for many programmers. So writing tests, so that we don't write tests, we'll let business people write tests for us. It's always a good idea, instead of us programmers thinking, I mean, how it happens in real projects. We're sitting together developing the software, and then somebody from the business side, from the marketing department, they come to us and say, hey, when our customers, they click this button, they expect to see their balance on the right side of the screen. But now they don't see the balance. So they want to see how much money they have, and then they can continue. Now you don't show them the money. Please do it. So all of that, which that person said, would be much easier if that person would write it down in the form of a test and just send us the scenario. And then scenario say, I go to the page, I move the mouse to the right corner, what I expect this number. Given I have a web page with this account, when I move the mouse to the right corner, then I see the balance in this font, I see this number. That's it. But what happens in reality, we listen to that person, to that marketing person, then we write down the test like this, or maybe not like this, we write down the Java test, which takes time for us. We interpret what they told us. And many mistakes happen at this stage, and this interpretation. We listen to them, but we don't understand entirely what they mean. We just understand how we understand. And this miscommunication between marketing and business people and programmers is one of the biggest problems in software development. We listen, but we don't understand. We encode, then we show it to them. When it's in production, they look at it and say, no, I didn't mean that, I meant something else. And again, the cycle goes again, and again, waste our time. It's very annoying for programmers. That's why people invented that. They said, hey, this is the format for you. Just learn this language. It's not Java, it's not JavaScript, it's simple English. There are maybe 20 different words which you can use. This is the vocabulary for you. Learn it. It's one page. And just write for me like this. And people will do it. So maybe it's not a bad idea. I mean, I use it in all my Ruby projects, I use it. But just because in Ruby I know there is Cucumber. I don't use it in Java, I don't use it in Rust, I don't use it in other, because for some reason in Ruby it's popular. I don't know whether it's popular, because maybe Ruby is known for DSL, for special languages. I don't know. But I think that BDD is what you need to know about.